Okay, so welcome to the part two called Describing Graphs for test corrections for our kinematics graph assessment. And so you just realize that we have to pay attention to what we are actually graphing. And right now what we are going to do is we're going to look and see how can we describe graphs using several different things. So whenever we look at a graph, there are three things that we can do. We can either look at the value of a graph. Sorry, I'm trying this new system, so I'm trying to get used to writing on here. Oh boy. We can look at the value. We can look at the slope. This may get rough. Or we can look at the area. All right. So these are the three things that we can do to look at a graph. So if I were to draw a graph right here, and I would put a couple different values here. So here's my x and y axis. And so I haven't described anything yet. In red, I'm going to draw a graph. Best I can, I'm drawing a straight line. And so on here, we see this straight line. And so I can describe what the value of this line is doing. So the value of this line should be increasing. We can describe how it's changing. So it's increasing. We could also say it's at a steady rate. And then we can also say its sign. It's positive. And so when we say it's positive, we're going to have to apply that to what it actually means here in a minute. Okay. But it's increasing and positive. If I were to do a slightly different color, coming down the opposite way, I want you to think of how would you describe the value of this graph? Well, the value of this graph would still be positive because it's above my x-axis. But this time it would be decreasing in value. Remember, I'm talking about value. So I'm talking about what the actual value is for the y-axis at a given point. So it would be decreasing and it would be negative. We can get a little bit more complicated by putting in some terms. And so I'm going to do one example like that. We already did that color. Let's do green. And so I'm going to say we're going to do something like this. And so for this green example, I want you to realize that we could begin slowly changing our value. So here our value starts at 0. So we can describe it as starting at, and then some value. And then we can say what's happening. So it's increasing here. It's becoming more positive. So what I'm just going to say, let's go with it's becoming more positive. All right. More positive. Now, for the sake of time, it's not possible for us to do so many examples. There's infinite number. Notice I didn't do an example where I was below my x-axis. Actually, you know what? I am going to do one. So I could have a graph that looks like this. I want to describe its value. I'm going to do that real quick just as an example for you. So notice my value is in the negative range. So it's down here. And so I'm going to say that my value is negative. All right, my value is negative. But I'm going closer to 0. So right here would be 0. But I'm decreasing value, or I'm heading positive. Heading positive. There are so many examples, guys, that we could talk about. And so the purpose is we need to do the best we can to describe our value. Now I'm going to jump over to our slope. And so when we describe and talk about our slope, I can have 3 different types of slope. We've already talked about this. We can be positive. That's when my slope is going up. We can be negative. That's when my slope is going down. Or we can be 0, and that's when I'm flatlining. So these are the ways we can describe our slope. And we can also have either a constant slope. So our slope can be constant, or it can be changing. And when I say changing, we have to explain how is my slope changing. So is it becoming more of either positive or negative, or is it becoming 0? And then what did it start at? So if it's changing, we have to say, how did it start? And where is it going? And for the purposes of this, I can only do one example. All right, here, if I'm trying to describe this slope, we have to say, is it positive, negative, or 0? Well, that's easiest to say if it's constant, but my slope is changing. So what we're going to do is we're going to describe this according to the beginning slope. So if we look at the beginning here, it's kind of close to a flat line. And then the farther we go, the more angled up it gets. So I would describe my slope, and just for the sake of understanding, I want you to realize that we don't even need the axis here in order to talk about the slope. So though I might have a graph, remember, I don't even need the axis. That's just extra. Because I'm not reading the value. All I'm reading is the line and what's going on. So here, I would describe this as starting. So it starts 0 slope, and then it becomes, more and more positive. Okay, so my slope starts 0 because of this flat line here, and it's becoming more and more positive. Now, why are we doing this? Okay, first off, area we're not going to so much describe. That is mainly for the situation where we have a object or a graph of something, and we know that we can best figure out what we are looking for by talking about the area underneath the curve. All this area we would look at, ooh, this is terrible. Anyway, all the area between the curve and the x-axis, even if it's a straight line, that's still a curve. It's positive if it is above the x-axis, it's negative if it's below the x-axis. So we're not going to talk so much about that, because what we need to do is, let's say we are given a graph. Okay, so here's our graph. Let's do one we haven't done yet just to prove how we can describe it. And so let's start with a very like this. All right. So just from the last video, you saw we have to first realize, what are we graphing? Well, we're always going to have t on our x-axis for these sort of problems. And then on the y-axis, we are going to have various things. So we are going to have, let's say, displacement or position. Now, why do we need to know how to describe the value? Well, we should remember that if I look at the slope of this, that is telling me my velocity. So any of these words from the left that I would use to describe my slope, that's what I would use to describe my velocity. So let's describe the slope here. If we look at our signs, positive, negative, or 0, remember we can ignore our y and x axis. I'm just looking at this line right here. This line here. And so my slope starts off looking like this. So it starts off very positive. Very positive. And it's going towards 0. Very positive to 0. And so the language I use here, I can exactly use that language to describe my velocity. So my velocity is in the positive, so it begins moving in the very positive direction. So the positive direction, and it is moving to 0. Well, 0 what? Well, I said 0 slope, so now I say 0 velocity. So to 0 velocity. What does this mean? What's another way I could say this? Well, I'm moving forward. So another way I could say this is I'm moving forward. But I'm slowing down because I'm going to a speed of 0. Moving forward, but slowing down. The main thing I need you to get on this video is that how we describe our slope or how we describe our value means something. If I have a new graph, let's say we have one that looks like this, but now it's a time graph and a velocity graph. So I need to be able to use the language that I use to describe my value here. So here my value is, well, let's look at it. It actually looks exactly like this red one. So here I am increasing value, or increasing my velocity, because that's what my value is over here. Increasing velocity and positive. That's what I was looking for. It's a positive value. And so the way I describe that is my velocity. But remember up here, if I have a slope of my position graph, that's also my velocity. So now the language I use here to describe velocity, sorry, I could have said positive velocity here too. So I'm just going to copy that. If I go on my displacement graph, what we should see is that I need to have an increasing slope. Oh, also we could say the value here started at 0. So my value starts at 0. So my value starts at 0. So my slope needs to start at 0 for my displacement graph here. And so now my slope needs to be increasing and positive. So my slope started at 0, needs to be increasing and positive. And realize I could have plotted this thing. I could have started here. Here I'd still have a 0 slope. And I would have gotten the exact same thing. I could have did it way down here. Gotten something exactly the same. All of these are described by this graph. And so the trick we need to realize is that as we look at a graph, we need to figure out, do I look at the value to describe what I'm asked of, or do I look at the slope? And there's a handful of times where we're asked to find the area. That's less common. So we're not going to talk about that here. That will become more useful later. So go ahead and go to the problems that are linked next on your test corrections on my website. Do your best to find them. You're going to be asked to look at a couple graphs, and then you will need to think, okay, I am looking for something based on the question, so you need to decide, are you looking for the value or are you looking at the slope? Like I said, we're not going to do area now. Value or the slope. I want you to signify which one that is, and then try and come up with an answer and justify your answer. And then I will see you shortly on the next video.